just x. So my domain is negative infinity through positive infinity. I'll see that right now even before I sketch it. Some students may know what f of x is equal to x, or if you wish, make it reflect back like this when you saw it, maybe y is equal to x. Would you want to recall what that looked like as a sketch? Is it a circle?
That would be the horizontal line.
Not horizontal.
Um,
Now I can do a table
Vertical.
and plot points. Yes?
That would be diagonal.
A diagonal? And tell me more about that diagonal. Let me squeeze in here, guys. Right here. A diagonal line, he is correct. And I can plot points if you wish. Make sure he is correct. Does anyone think they know after you plot a few points, maybe connect them? What does that graph look like? It is going to be a diagonal. Tell me more about the diagonal.
Linear.
It's linear. Thank you. It is linear. Straight line. Tell me more. Now, what I'm asking is, and I'm going to mark it here, is it a straight line? This is a diagonal here. Is it a straight line doing this? I heard someone say it. Through the what?
Origin.
Through the origin. It goes through 0, 0. It's like this. And they label that as the graph of f of x is equal to x. Now, I don't have the time, you don't have the time either, but if you say, Professor, how do they get these graphs? They've done something you did back in middle school, probably. They did this. They formed a table and randomly replaced x by numbers, maybe. Maybe, who knows, maybe -2, 0, 3. And then it says f of x is equal to x, y is equal to x. That would be, this is the same, this is the same, this is the same, y and x are both the same number, and then plot those points and connect them. And that's how they got that diagonal going through the origin. So they've actually used a little table on the side there. So that's what that looks like. Oh, by the way, can anyone tell me what the range is?
All real numbers.
All real numbers. It's going up forever, dropping down forever, and also the domain is negative infinity through positive infinity. That's the first basic one. And you're going to get a handout with all these. The next one, I think every student in class recognizes this one. F of x is equal to x squared. Graph into, what's that curve known as? A parabola. So write quickly if you want to see its shape of this, and you may go through a table if you wish. I don't think you really have to do it though. I'll just make it real quick. So if I see something with an x squared, and we're asked to graph it, which later on we'll be graphing lots of them, I know to expect a shape that looks something like that. F of x equal to x squared. Its domain,
All real numbers.
thank you, all real numbers, I'll write like this. Now the range, since I do have the sketch in front of me, that range is the up and down, the y values. It drops down to a low of 0. It hits the origin. Then it rises forever, write this in bracket, 0 through infinity. Just to do a little summary of these. Next one. F of x is equal to x cubed. And I could form a table, plot points, and connect them and get a shape. I think though many of my students, quite a few, I think you might recognize what y is equal to x cubed as a graph looks like. You want to have an idea? Now I'll tell you ahead of time, it's not a straight line. It's not a parabola. That's another one of those that they expect us to recognize if I see an x cubed. Go for it.
You mirror the first half of the parabola on the
You mean like this?
Obviously, no.
Okay, and two more.
So you mirror the
Down
first-
here?
Yeah.
So you're telling me all together, Professor, if I plot points, we can form a table, connect, it may look something like this.
Yeah.
And there's a graph of x cubed. Almost like a little snake there type. Now, domain is easily seen from left to right, go to the x's, it's open. And just so happens the up and down, the range is open. That's what we're looking at. Number 4, we've discussed this one in class, but I don't think I've shown you a sketch. Square root x. That's another one of the care functions, basic functions we're responsible for. Square root x, I like to get a quick shape of it. And let me see if anyone in class recognizes what its shape looks like. Oh, yes.
It's gonna be like it's gonna be the parabola, but rotated 90 degrees, and then the bottom half is just the top half.
Just the top half. So you're describing perfectly this right here. Or something like that. In the first quadrant. That's it. Now my domain on this, by the way, now since you know that, is to be accepted as your parent graph for the square root, the basic graph representing square root. Its domain, easily seen now, and the domain is associated with the x's. You put an x here, of course, y here for the range. The x is from 0 through infinity, which we would expect for a square root. That x underneath there must be that. Range, the up and down, it looks like it drops down to a 0, and it rises forever, so the domain and the range in this case are the same. 0 through infinity, 0 through infinity, there's the domain and the range. So right now, if I were a student, I know what's on your mind. Right now, I know what's on your mind. If I wrote on the board 5 plus 6 is equal to 24, you would accept it. You would sit right there and say 5 plus 6 equals 24. Professor, I see those hands nodding. Hayden would be nodding his head. Miles should be nodding their head. Professor, that's true. Because I know what's on your mind. Not this. What's on your mind? Yes. So professor, put anything on that board you wish. I'll take anything, professor. Put anything on that board you wish. I'm not going to argue with you today because my mind is elsewhere. Okay, so guys, at least this is what's coming up in this next part of the functions. Now though, I want to do this. There are some unusual ones. Number 5, I'm going to do one more here. F of x is equal to, and many of my students may recognize it. First, what does that represent? Absolute value. Okay, now I could do this, form a table, plot points from that table, connect my points and get a sketch. But since I'm cut short on time, does anyone think they remember what the absolute value of x looks like as a graph? Katie?
Is it like a V?
It is. It's a V shape. Like that. And there's your graph. And you can actually plot points to get it. By the way, Katie, since you gave this to me, the domain, keep in mind the domain instead of x's was like on the x, it extends from left to right forever. So the domain is this. Range though, range is the up and down, that's the y. How far down does that V-shaped graph drop?
0.
To a 0, then it rises forever. So bracket 0 through infinity. And that's that. Now, I'm looking at the clock here. Number 6. Number 6 coming up is not one of the parent graphs. But, to get ready for the work next week, would you guys want to come in tomorrow also? Meet again? Any volunteers come in tomorrow? Mr. Park? We'd come in, wouldn't we? Would we come in another day? Maybe Thursday? Friday? Any volunteers? Oh no, so I'll have to wait till Monday. Yeah, what's what happened here? When I do see you, I'm excited about this because it's going to open up all type of questions here. Suppose, Professor, the graph, real quick. Looks something like that.
Piecewise function.
First, is it a function?
Yeah.
I'm talking about functions today. Do you think that would be the graph of a function? I think we discussed this the other day. What's a quick check? Vertical line test. The vertical line test would pass here. So this is a graph of a function. It's not considered one of the basic functions like these. That's a function. All I want to point out here is, can you look at this and tell me, even though it looks strange, what is the domain, do you think, from left to right, the x-axis? How much of the x-axis is being used from left to right on that graph? Everything. Negative infinity through positive infinity. Now the range should be, those are the y values, that's the up and down. Does it drop down forever?
Yes.
Does it rise forever? My domain and range in this case are the same. Now, close down. Let me get close here. I need to mark a few things in this graph. I'm gonna say this point right here. Yeah, so let's see there. Has an ordered pair of -1 up 2. I'm gonna label this point. I'm gonna say this point right here is out 2, down 3. I'm gonna say this point right here is, right on the x-axis, is -3. This one, I'm gonna say is -1/2. I'm gonna mark this one as a 4. Beautiful, beautiful. I got a few questions and we'll close down. Okay, here goes. Got a strange graph staring at you. It says, Professor, domain and range. I understand domain and range, Professor. I'm gonna have domain on the test tonight. Domain and range here on the graph. Now, if it does come out to be something like this, here's a question. I'm gonna look at this graph from left to right. As you look at it from left to right, are there parts of this graph rising? And are there also parts of this graph falling as I go from left to right to complete the graph? So they describe this as, in mathematics, as, when is this function, this represents a function, when is this function increasing? Let's get that part out of the way first. Where is it rising? Now we'll go from left to right. Guys, if I go left to right, we'll shade in, if you guys will agree. Does everyone agree that this piece from left to right on my red graph, as I travel from left to right, is that piece rising? Can anyone tell me in interval notation, when does that happen? They want to know, when is it happening? When is it rising? I see I've shaded it's rising, increasing. When is it increasing? Can someone come up with a good way to recognize what interval is it? I see all kinds of hands going up. Increasing. Yes, sir.
So minus infinity until what number is that?
-1?
Yeah, -1.
He says negative infinity up to a -1, Professor. It's rising. Is that true? It's dropping down. I realize it's dropping down. But what?
Wouldn't it be a closed bracket?
Now, if I put a closed bracket, tell me what's, now listen to my description. If I put a closed bracket, and I think your textbook might put a closed bracket, I'm not going to in this case. Tell me why I would not, even though I would not, kind of problem. Why would I not put a closed bracket? Right when you reach -1.
It might be considered flat.
What's it doing? Is it increasing? What's it doing? What's the graph doing at -1? Is it still rising? No, it stopped. That's a stationary point. Okay, so if you did put a bracket, I'm not going to count it wrong. I prefer a parenthesis because it really has stopped. It's not increasing at that point. Now though, is there another piece of this graph that's increasing besides the one he gave me? Is this piece right here also rising? Now can anyone describe for me in interval notation, what would that look like? How can you tell someone that that piece is also increasing, rising? Go for it.
It's rising rising from 2 to infinity.
So I'm gonna just do this, I'm gonna put union, 2 to infinity. And that's the increasing part. Decreasing, falling. So I'll get this out of the way today. Guys, the part that's falling, I think, is, as you go from left to right, is this piece right here. That little piece is falling. Now, how would you describe to someone in interval notation, when is that taking place? From what to what? Yes,
It's minus 1 to 2.
negative 1 up to 2. Written like this. There's increasing, decreasing. Now, here comes a question. Another question for you. Is there a point on this graph that when you find it, you look at it, that it's higher than all points nearby it? Is there a point on this graph, when you see it, you look at it, it's higher than all points nearby it? Oh,
Negative 1, 2.
right here, this point right here is higher than its neighbors nearby. It's the highest point. Is there a point that you see on this graph that when you look at it is lower than its neighbors? Is this point right here lower than its neighbors on the other, both sides? Now, if I find that, then I'm going to ask you another question here. Is there on this graph a point that is the highest of all points? It is the complete highest point on the graph altogether. Is there a point on this graph that would satisfy that description?
No.
It's higher than every point. Can I identify a point? Why not? Is this going forever? So there is no highest of highest. If I ask you where's the lowest point of all points, I can't do it because this thing drops down forever. So there is none. Now those two that we identified earlier, Paul, you help me out here. We call these local, in that particular locality, a local maximum value shows up as he gave me, negative 1, 2. In that particular locality, that's the highest point I see. Now, if they ask you what's the value there, they just want the y value. It goes up to a 2. If you listen to the entire point, negative 1, 2, I'm happy. But they just want the y value. This one down here is a local, in that particular locality, minimum point. You guys was list the y value, so drop down to a minimum of negative 3. And there is no other points there to look at right now. How's that look? Now, last question. You. I'm going to close this down. Or name a function for you. I know tonight you'll probably factor that and try to come up with its domain. Got what the x squared, the domain of this. No square root to worry about. Just 9 subtract x squared. If I graph this, and we can graph it by plotting points, but I just want to see its shape real quickly. Some students may know what it's going to look like. I will go up to 9 here. There's going to be a negative 3 involved, positive 3. That should be a 9. And you're going to get a graph that does something like this. Like an upside down parabola. That's a shape. The negative 9 subtract x squared. Right now, I just did it quickly for you. I'll tell you more about this next week. My question is, here we go. This is now connecting with the test tonight. Suppose on the side here, on the test tonight, you were asked to do this, and I'm going to close it down. how would you deal with 9 subtract x squared? I now have a graph now. How would you deal with 9 subtract x squared is greater than 0 for tonight's test? What would you do? I want you to solve that inequality. How would you do it?
3 minus x times 3 plus x.
Oh, someone's ready. 3 minus x, 3 plus x. 100%. And what's that beautiful method we like? Sign analysis. Is that true? So if I go to sign analysis, I'll close this down. If I have critical numbers of -3 and +3, we take a close look. These are open. And then of course you go through what? Do test, find the values to test. And to save me a little time here, guys, I think, let me check it right quickly. Out to the left, maybe a -5. You put a -5 in here, I think you'll end up with a positive and a negative. I'll do it fairly quickly there, which is not gonna work for what I need. In between, I'm gonna try 0. Put a 0 in there, you end up with a +3 and a +3, that's definitely gonna be a positive. And that's what I was looking for. Therefore, all that's shaded. Out to the right of 3, close this down, we'll try 5. Put a 5 in here, 3 subtract 5, of course it's gonna be a negative. 3 plus 5 is gonna be a positive. Negative, which I do not need. My answer then, like you're doing a test tonight, would be after all this business with sign analysis, you say, well, Professor, the answer is in integral notation, -3 up to what? 3. Is that true? Yes, no? Now, next week, will be much easier. Anyone tell me, since I now have a picture of a graph of, here's this graph, here's this picture. And I'm asking this question here. Here's what this translates into for next week. You may not have to do it by sign analysis. If you have the graph on the side there, this tells, or it's asking me, when is my graph above, greater than, above the x-axis? When is it above 0, which is the x-axis? Please tell me, is this graph above the x-axis for this portion here? Is that the piece of the graph that's above the x-axis? And when is that happening?
From -3 to b.
And you just solve the problem. No sign analysis touched. Just to note up when it's the graph above the x-axis. You're finished. Wow. Guys, we did it. We got 10 minutes. Enjoy your 10 minutes.